So this is the second one on that list. So again, you guys are welcome to cut that apart and glue them in your notebooks. There's scissors and glue sticks in the clear boxes on the table if you want to. Not saying you have to, but whenever we have a day that has like a gazillion story problems, I do my best to print them out so that we don't have to waste our time writing paragraphs, because that's a lot of time. So this is number 2 on that paper. Sorry, there we go. This is 2.2. 2.2. I'll put that up here just so we have it. Yeah, 2.2 is all story problems. All right. So we've got here that somebody's take-home pay is $492 after the deductions that are 40% of gross pay have been subtracted. We're going to try and figure out what the gross pay was. So the pre-tax. How could we set that up as an equation? What can we do? Yeah. So we know it's going to do something to do with this 40%. How do I write 40% as a decimal? 0.4. So we need 40% of the gross pay. How do I do 40% of something? Multiply it. And again, you can use X if you want to. I already heard somebody say X. You can use something related to what this is. So the gross pay, I could do a G. You could do any number. You can use your initials. You can use happy face. You can use heart. I don't really know. So that tells me 40% of my gross pay. But it's not that 40% of my gross pay is the 492. What do I need to do in order to have 40% of the gross pay have been subtracted? Yeah, we need to subtract the 40% of the gross pay, right? That's what it says. We're subtracting 40% of that from what? From the original, right? It's not from the 492. The 492 is their take home. So we're subtracting the 40% of the gross pay from the gross pay, right? This whole thing's going to equal our 492. That's where this is coming from. Our total is 492. The 492 is not what we're subtracting from. It's our answer. So we need to take what they get paid. So like we get $8 an hour. We worked for 40 hours a week. We're going to make a lovely chunk of money there, right? So my brain just totally. So we would make $320, right? If I made $8 an hour and worked 40 hours a week, it'd be $320. When we take away our taxes, that gets us to our net pay. So the gross pay is at $320. Then we got to subtract our taxes. So we have to take our gross pay and subtract the 40% of the gross pay. That is meant to be a G. So our gross pay, and we're subtracting 40% of the gross pay. So again, it's a lot of that reading. The hardest part of these is putting together the equations. Because what can I do here to simplify this? If I have G minus 0.4 times G, simplify that first. Because this is 1G minus 0.4G. How many G's? 0.6G. 1 minus 0.4? Okay. So if I have my whole net pay, or my whole gross pay, and I'm taking away 40%, how much is left? 60%. 60% is a decimal? 0.6 times our gross pay. Now we see where that piece came from? There are a whole lot of wait whats on the first one. Feel better on that now? Ish, maybe a little? What the heck can we do here? Divide by 0.6. Is that easy to do without having calculators?
No.
Without having calculators? How do I put 0.6 as a fraction? Because that might be easier. 6 over 10. Because what can I do to get rid of a fraction? Multiply by our denominator, for sure, to get rid of the fractions. So we know 6G, whatever our gross is 4,920. Right? It's a little bit easier sometimes to do it when it's whole numbers than when it's as decimals. Because now we need to divide by 6. So our gross pay, G, was $820. If you have a question, you have to talk louder. I hear this whispering, but I can't tell what you say. Questions on this one? Once we get the equations written, we're usually okay. The hard part is slowing down because we think the equation writing part should be the easiest, but that's where we need to have the most time. We're usually okay with the math parts. It's the writing of the equation that you need to slow down for. We're going to practice this a whole bunch of times. That is the whole point of today, is to go through these and practice writing these equations. So questions on this first one we did today? Okay. Next one. This is number 3 on that list of ones I got for you. So a person's IQ is determined by multiplying the quotient of their mental age and the chronological age by 100. I'm so good at talking. So, before I do anything with situations A and B, I want to get that into be something mathy that's not a paragraph. So, the intelligence quotient, IQ, we are going to be multiplying the quotient. So the quotient means we're going to do what with the two things? Divide them. So their mental age. So I'm just going to call that M. So we're going to take our mental age and divide it. That's what we said quotient meant. By their chronological age, meaning calendar age. So I'm just going to call that C. So that's my quotient. So we're going to then multiply the quotient by 100. That's what the last piece up here says. Multiply by 100. So then we're going to times 100. Does everyone see where all those pieces come from? So that's the expression we're going to use. So A and B are giving us specific values to put in. We're going to find the IQ of a 12-year-old who took a test with a mental age of 15. So how are we going to set this up specifically with these numbers? 15 over 12, so our mental age of 15 over 12 times 100. And you have several ways to go through this to try and simplify it. because we want to get this down to an answer that is not a product. You could brute force, go through, multiply our 15 times 100 and divide by 12. Anyone see a different path through this? Simplify the fraction. What does 15 over 12 simplify down to? 5 over 4 times 100. So that's simplifying that part. What is 5 over 4 as a decimal? 1.25. That is easier to see sometimes than 5/12. So we have 1.25 times 100. What is this person's IQ? 125. So that's our answer, 125. So then B is looking at it a little bit differently. They're giving us someone's mental age and their IQ. Oh no, we're asked to find the mental age, excuse me. We are asked to find the mental age. So we're not going to know M. We don't know that. So we're going to need that to be a variable. You can have it be M, you can have it be X. I genuinely do not care. We don't know their mental age. What is their chronological age? 15. So if we take whatever their mental age is and divide it by 15, then multiply by 100, that gives us our expression up there. And it should give us a total of 140. What are your thoughts for what to do next? What you got? Multiply 15 on both sides? Totally fine. That's going to give us 100 times M equals, so if we multiply this side by 15 and this side by 15, what is 140 times 15? I was going to say, if that's the way you want to go, that's fine, but you got to be able to do 140 times 15 without a calculator, because we don't get to use calculators. Totally fine. If you want to make it and divide by 100 to both sides, that's also okay. So you can do this in either order. It doesn't matter. We should wind up with a mental age of what? What do we get for M? 21. And again, you can either multiply both sides by 15 first and then divide by 100, or you could divide both sides by 100 and have 1.4 times 15. Sometimes we feel better with that. Either way. So the hard part is setting up these equations and finding the pieces. Let's see if we have. Okay. I want to make sure we get to 7 today. Questions on this one? All right. So this one is number 4. The cost of installing insulation in a 2-bedroom home is $2,400. Present monthly heating cost is about $200. However, the insulation is expected to reduce our heating costs by 10%. We want to know how many months it will take to recover the cost of the insulation. How are we going to set this up? First things first, what is our variable? What is it that we don't know? X, more specific, what is X meaning? How many months? So when in doubt, your question usually gives you a clue for your variable. So if we want to use X, we absolutely can. X is going to equal our number of months. And there are a lot of different ways to build this. There's a lot of different ways to build this. What is your instinct for how to put this together? Yeah. So for sure, we know it's going to involve something with our $200 per month. So we've got our $200 per month times however many months. That's our normal bill. Our new insulation is expected to reduce our heating costs by 10%. How much specifically do we save each month with our new insulation? $20. How do we know that? 10% of the 200. So we're taking our 200 every month times that 10%, right? That is the amount we're saving. So the amount we save, we want to know when that reaches what total? Our 2,400. We want to know when the amount we save, that 10% of our $200, is the amount that we paid for our installation. So we're taking our normal cost and how much we're saving, and we want to know when that reaches the total. So we already said our 10% of 200, we're saving $20 a month. We want to know when that equals our $2,400 that we spent. How many months will it take? Is 60 times 20, 2,400. 120. How many years is that? 10 years. So your insulation cost takes you 10 years to recover. After that, it's pure profit. So it'll take us 120 months. Okay. Questions on this one? Because sometimes it's going to be just like this, where it's one equation that we're solving. Yes, Megan? It's... Okay, right over here. Okay. So let's do the next one for sure. Yeah. We might do 5, then 7, then 6. I want to make sure we hit 7. So this one is number 5 on that paper. So we've got 600 people attended the premiere of a movie. Adult tickets were $9 and children were $6. The total box office receipts was $4,800. And our question is, how many children attended the premiere? How the heck do we put these together? What you got, Anthony? we can absolutely do the variables x and y for adults and children. So I'm going to have x be adults, and I'll do y to be children. If you pick variables like x and y, or your own initials or things like that, give me one of these lines. It says x is the adults, y is the number of children. If you use A and C, I can probably figure that out. But if you're using X and Y, tell me which one's which. Go for it, Anthony. X plus Y equals 600. That is definitely some of the information we have. We know that however many adults we had, combined with however many children we had, is a total of 600 human beings. There were 600 people in the theater. So that's our first bit. Hold it just a second, Anthony. To be fair, I know you know how to build these. You learned it from me. So that's our 600 people that attended the premiere of the motion picture. So everyone see where that came from. How can we build the other equation? Give someone else a chance here. Go for it. Yep. Our 9 times however many adults, so $9 for every adult, and $6 for every child, is our total budget of $4,800. What the heck do we do from here?
Eliminate.
Go for it. Valid approach, also a valid approach. So you can either do it where we set it up for one variable and do it as a substitution, excuse me as I choke on my words, where you get to an x equals or a y equals and plug something in. You could also do it with an elimination style, where I multiply, probably the top equation, by something to get one of our variables to eliminate that way. Both are valid techniques. And you can go either way. So try that. I'm going to pause my screen for a second because I'm going to write both up here because 100% both are equally valid. So try it. Do that. Do it as yours. Whichever way you want to go. I'm going to do both. All right. What did we get for the number of children? 200. So this is our substitution method where we set it equal to one variable. So I did this one with substitution. I got this equation to be an x equals so that I could substitute it in right here. And then it got me down to a single variable, and I got my y equals 200. I'm going to change the view just so you guys can C. So this was our substitution method. Option 2 is either called elimination, or it might have been called linear combination, depending on who you learned it from, but it means the same thing. This is combination. This is where you take our two equations and you multiply one of them. I took my top one and multiplied it by -9 to get my x's to cancel out. And then I add things in columns. So in Algebra 2, you spent like a whole chapter working on these kinds of pieces. Our substitution, where we take an x equals or a y equals and we substitute it in. Or our elimination, where I multiply one or both of my equations to get one of my variables to cancel out. Questions on this one? Because I see a lot of very lost looking faces. How are we feeling? Great, okay. Not too bad. It's like, we've seen this before. I know we've seen it before. But it's just like deep storage. So we got to bring that back forward. So we're feeling okay on that one. We're going to jump down to 7 and then we'll come back to 6. I want to make sure we hit 7 because there's one that doesn't work. Yes, my dear. I took my x plus y and I multiplied it by -9. So I took my x plus y, -9 times x gives me -9x, -9 times plus y gives me -9y. I chose -9 because that made my x's cancel out. 9x plus -9x gives me my 0x. So I picked the -9 to multiply this top equation by so that my x variables would cancel out. I multiplied this whole guy by -9. Okay? Okay, so I want us to jump down to number 7 because I know there's one like that on the homework and we see those pop up lots of places and it's worded kind of weird. So it's vaguely similar to this one, in the fact that we're going to have more than one equation. So I want us to do number 7. And then we'll probably jump back to 5. I just want to make sure we practice this. So we've got a medical test designed to measure carbohydrate tolerance. And for the adult drinks, they have 7 ounces of 30% glucose solution. When the test is given to a child, the glucose concentrate must be decreased to 20%. So we want to know, in order to make that glucose solution, how much of the 30% glucose we should add and how much water should be used to make the 7 ounces of 20% glucose solution. So it's worded super weird. My first question, what don't we know? How much water should be used? So there's one variable. What else don't we know? How much of the 30% glucose solution? We have 2 things we don't know, which means I need 2 variables. So you can use G and W. So G is my 30% glucose solution. I'm just going to write it down. Oh, sorry. Let me lock the page out so you're not following my zooming in all that much. And my W is going to be how much water. Okay? So those are the variables we're using. It's the amount of glucose and the amount of water. What can we do to build our equations here? I know that combined together, my glucose combined with my water should total up to what? 7 ounces. So combined together, the total number of ounces, we should have our glucose, however many ounces of glucose, and however many ounces of water equals 7 ounces. So that gives me this piece, the 7 ounces. How can we put together about the glucose percentages? So we're going to be building a separate equation. How much glucose is in G? 30%, right? 30% of our ounces, right? So 30% of G, right? How do I write 30% as a decimal? 0.3. So we have 0.3 times however many ounces of glucose we have. And we're going to combine that together with how much glucose is in water? How much sugar is in water? None. So we have 0 glucose in water. Ideally, we should not have sugary water. At least not when we're mixing prescriptions. That's what glucose is. Glucose is a sugar. And we want to know when that combines together to make how much? 20% of 20% of how many ounces? Of the 7 ounces. So it's always going to be percent times our ounces plus percent times our ounces equals percent times the ounces. This one's weird. That's why I wanted to make sure we hit this one. They love to throw out these random pharmaceutical questions. They throw these out a few times. Okay? I'm just saying. I've seen this one pop up before. In things like tests and or quizzes and or finals. They love these kinds of questions. I can't guarantee it's going to be on, but it's been on previous year's finals. So they've had questions like this. That's why I wanted to make sure we hit it.
What about the SAT? Do they do
It's possible, but it's a little bit hard mode for SAT. It would probably be like the hardest kind of question on SAT. Just because of all those percents and decimals. So, questions on the building of the equation. Okay. So we're going to solve this the same kind of way. We're going to do some simplifying. We're going to try and do some substitution. What do we see here that we can do to solve this? What do we notice? I'm going to extend my page down a little bit and change the view. So the paragraph no longer matters. Context no longer matters until we get to the end for our answer. If I just gave you these equations, what do we notice?
multiply use like substitution,
We can absolutely use substitution if we want to.
elimination?
We could use elimination if we want to. We can multiply the 0.2 and the 7. What else is kind of nice in this second equation? There's a 0. We love zeros. Because this becomes 0.3 G. 0 times W is just 0. And we need that to equal 0.2 times 7, which is what? Careful. 1.4. We might see this and go, ew, that's a lot of decimals. If you want to get rid of the decimals, multiply both sides by 10. If you hate decimals, which a lot of us do, but not everybody, you could make this 3G equals 14. Absolutely fine. What's G going to equal? 14 over 3. What is that as a proper fraction? 4 and 2/3. Okay. You can absolutely do it as 14/3. You can also do it as 4 and 2/3. So I know what G is now. What's W? Take our G of 4 and 2/3
Can we add it?
and substitute it in here. So we're going to take our 4 and 2/3
2,
plus W equals 7. So 4 and 2/3 plus what equals 7?
2,
Mm-hmm.
so you would accept it proper fraction. Mixed fraction.
Yeah. So how much water do we need to add to this mixture? 2 1/3 ounces. And how much of the 30% glucose do we need to add to the mixture? 4 2/3 ounces. So our final answer would be we need 4 2/3 ounces of the 30% glucose and 2 1/3 ounces of water. And that would make the correct amount of the correct formula. I'm really glad I jumped to that one because we only have like 4 minutes left. And it's more important that we did this one than we do the other one. Because like I said, I've seen this one pop up in finals before. It's in the 4 finals that I have access to, a question like this popped up on 3 of them. So they write a new one every year, so I cannot make any guarantees. I won't have it until probably the first week of December. So much fun. And as soon as I have it, I will write the review for us so that we have a review that gets us through everything we need to. But these kinds of questions have shown up on previous year's finals. I can't make any guarantees, but they have shown up. Okay? These problems take the most time in the equation writing part. The equation writing part is where I need you to pump the brakes most frequently. We always feel like we're going to write the equations really fast and it's the math that's hard. It's the equations that's hard. You guys are good with the math. We're good with that. It's the equations I need you to slow down on. Because if the equation's wrong, you have no chance. The equations are the hardest part. Okay? Please make sure that you check your email. You should have gotten an email from acp@indiana.edu. You will need to create your IU email address and do a Duo login. It's an app that you have to download. Okay, I'm going to kind of talk you through these steps over the next couple of days. I'll give you little steps each day. You got to create the IU account. You have to make an IU email address. You should have a username that's been emailed to, and this information should be in the email from acp@indiana.edu. You should have gotten that. Okay, so this address has all the information you need to set it up. The access.iu.edu/starterkit. That is your congratulations, you've joined IU first website. Okay, so I'll give you little steps to go through each day, but you need to set up the account first. That is super duper important. You have to do this even if you do not plan to get the IU credit. You have to register for it. So even if you're not planning on doing the dual credit, you got to do this. So you've got to set up the Duo Authentication, which is an app that you download on your phone. Yes, it's obnoxious. I'm sorry, I had to do it too. I've got 4 different Duo accounts. It's annoying. But whatever account you set up your Duo on, make sure it's something you carry with you. So don't set it up for your iPad that you leave at home, because every time you log into IU, you need to have that device with you. Okay? Make sure you get that set up. I'll give you more steps a little bit at a time as we go through. Okay? Because I wanted to make sure we hit number 7. That was really important. So, 2.2, you guys can do everything on. I will make it due Wednesday because we just talked about it today. So, 2.1 is technically due today. Turn in 2.1 if you have not done so yet. I'm going to make this one due Wednesday because I just kind of talked about it.
I looked up the email.
Okay, the guidance counselor things are back there. Contact Ms. Bolland. She's in charge of the DC kind of setup thing. Okay, so if you haven't got it yet, send Ms. Bolland an email. Have a great rest of your day, guys.